Good day, gentlemen. Welcome to Outside Plant Civil Construction Guidelines training presented to you by STC. In this training, me and my colleague Mr. Usman Mirza will present to you the requirements, steps, and procedures in the civil implementation phase. By the way, I'm Dexter Germinal, your design and implementation guideline support in Central Region. After this webinar, attendees should be able to understand the following: important considerations on civil implementation, surface breaking, trenching and excavation, duct handling and installation, duct configuration and formation, crossing requirements, tests on microducts, backfilling, surface reinstatements, milling and paving, test on asphalt, manhole and handhole installation, installation of cabinet base, installation of protection posts and U-guards, ball handling and installation, marking and identification, and finally, civil work acceptance and quality assurance. Okay, guys, before we move on, we need to somehow discuss about the important considerations in the implementation guidelines. Okay, as a background, the responsibility for the build of network infrastructure for STCs can be on a public land or domain or on a privately owned property. The telecommunication standard references requires separation between different underground utilities. Any trench installation not meeting these requirements will be non-compliant without exemption from STC. The designer or the contractor will need to supply STC exemption as a component of the civil works acceptance. Okay, so trench containing STC cables and the associated ducts are to be positioned in the straightest possible alignment to accommodate the future cable installations. Okay, so undertaking of trenching shall meet the requirements of STC and any other relevant specification imposed by local authorities, ministries, and regulatory authorities. A non-compliance notice will be issued for any civil works where remedial work to the trench is required. Okay, so if there is any query relating to the requirements of these technical standards, please contact the inspector responsible for the project. So what are the contractor's responsibility? The contractor or an agent of the contractor shall be responsible for the following. You make sure that all street, ground openings, all costs associated with the compaction, reinstatement of road or footpath surfaces, and services where disturbed or damaged are to be the satisfaction of the authority or owner concerned. Number two, the safety of the open trench and any liability arising from the customer's work. This includes ensuring that there is a suitable clearance between any excavation and existing STC networks infrastructure. Also ensure that the necessary arrangements are made with the local authorities and public service utilities for the temporary disturbance of any driveway, culvert, dock, drain, footpath, survey mark, etc. The testing phase will not be undertaken until the STC representative deems it appropriate following the approval of all other networks. So in this slide, let us discuss the different requirements that each contractor must have to obtain prior to commencement of any civil works. Number one in the list, access permit. Access permit, as you know, guys, is very important whenever you work to an either publicly owned property or a privately owned property. Before trenching, you make sure that you have properly scanned the ground by using a radar scanner to avoid damage to existing utilities present underground. Because once you have hit or damaged these utilities, the contractor is liable for the restoration and cost of all damages in the field free of charge to STC. You always need to be careful when working to a live STC network because there is a big tendency that the technician might damage them. STC cables should always be treated as energized or live. So if you guys are unsure about the status of those existing utilities, please consult the owner to know more about the details. So second in the list, civil work notification requirements. As a contractor, it is mandatory to advise STC prior to commencement of any civil work. You should have informed STC inspection team 2 days ahead prior to implementation. It is also very important that you should not start any civil work without obtaining the required permit from local authority, ministries, and municipalities. Okay, so let's move on to emergency work requirement. By the way, what are those emergency work? These are the works which are unforeseen. Example, cut cable hit by roadworks contractor, STC infrastructure damaged by fire or something, road construction, pilferage, and many more. As a contractor, your responsibility is to inform all parties affected within 24 hours verbally. In the event of any dispute, the contractor will be held liable with local and regulatory authorities. Okay, so what about civil work compliance requirements? All telecom networks done by the contractor must be compliant with the relevant codes and standards required by local authorities and STC standards and guidelines. Okay, so STC has the right to refuse any civil networks built by the contractor that does not meet or conform with the STC standard and specification. Okay, okay, so let's discuss about the requirements of change to civil works. Basically, implementation team will always and cannot avoid these circumstances if there is no proper survey in the field prior to design. Okay, so these changes in civil works could either be due to road construction, obstruction brought by different factors, permit issues, duct blockages, etc. Okay, so if you face these issues, immediately inform your designer to locate the best possible route and reroute the network based from network engineer. Okay, so contractor must prepare CO2 CO9, which is a site instruction. Okay, signed by the inspector and approved by senior designer and project manager of STC. After obtaining all necessary requirements, then you guys can resume or begin the execution. Okay, so what about permits and coordination? As a requirement, contractor is responsible for obtaining all necessary permits and permissions from all concerned agencies prior to commencement of any civil works. Any doubts in the field prior to civil works must be well coordinated to the owner of the network. Contractor shall submit permit crossing certificates from municipality or MOT with path document and keep them for future use. Okay, so for the work and safety and clearance, a contractor shall ensure and practice safety procedures for safety of staff, pedestrians, and traffic at all times. Warning signs, fencing, traffic barriers, and all precautionary measures shall be provided to each job and maintained to safeguard and cause minimum inconvenience to the public. Flashing amber warning lights shall be operated at night to prevent from any accident. Okay? So detailed hazards and safety assessment management plan form should be filled by the field contractor prior to commencement of any work. As a matter of courtesy, the contractor shall send a written notification letter to the owners of the affected premises buildings prior to commencing any works. Okay, so local authority directions shall be followed if so required. Pedestrian access shall be provided at 100-meter intervals, and crossroads shall have decking provided to permit the passage of vehicles. Okay, so personal protection equipments such as boots, reflective vest, okay, jackets, gloves, protective helmets must be worn at all times by the on-site technicians and laborer. The minimum level of disturbance with respect to inconvenience of noise, pollution, and damages to the surrounding area and neighborhood should be maintained to a minimum at all times. All debris shall be removed from the work site, okay, to the designated area specified by concerned authorities. The site shall be restored to the condition in which it was found, always. A contractor shall post his name, okay, emergency contact number, address, municipality permit on a board and installed near the work site prominently. Okay, so in this slide, let's talk about the separation from existing utilities. As you know, guys, there is a prescribed designation or assignment of each utilities in the sidewalks or carriageway. From the building line, first assignment goes to the electric utilities. Then you have the oil, gas, steam, and petroleum. Third assignment is given to the telecom sector. Then water, sewer, temporary survey marking, proposed excavation work, and so on. And with regards to the telecom utilities assignment, a 2.5 meter from the wall is given to them to install their infrastructure. However, for long distance network, easement of telecom infrastructure dictates the size of the road, and you will see that later on in the next slides. Okay, so to be able to prevent occurrence of any damage of any existing underground utilities, a ground scanning using a ground penetrating radar is very important, and also observe a 50 millimeter trench separation from existing utilities as well. So for long distance network, the clearance from the STC assets to other service utilities assets shall not be less than the minimum recommended separation as shown in the table below. So if we have these utilities, for example, water mains, we have these sewer ducts, we have manholes and joint boxes, make sure that the parallel distance, if the road is more than 10 meter, make sure that the parallel distance must be 300 millimeter. And when it is a crossing, okay, if you are crossing, please make sure to maintain 150 millimeter. Okay, And for other utilities like lamp standard, you have the bases, you have the traffic signal. Make sure that the separation between STC assets and these utilities will be 150 millimeter. Okay, so for power cables or for electric cables, okay, we'll have these different parallel distance. The road is greater than if it is more than 10 meter. Okay, so we have 300 mm for 600 volts. Okay, we also have a 1000 millimeter for 13.8 kV. We also have 2000 millimeter for 33 kV and so on. Okay, for normal trench in access network and trenchless technology installation, clearance from ST assets to other service utility assets shall not be less than the minimum recommended separations on the vertical and horizontal clearance as shown in Table 2. So if you have these utilities like water mains, sewer ducts, manholes, and joint boxes, this separation on a parallel distance must be 150 mm. And when crossing, please maintain 100 mm. For lamp standard bases, traffic signals, the parallel distance separation, okay, must be 100 millimeter. And for utilities, for other utilities like the power utilities, so power cables having a voltage of 600 volts, the parallel distance must be 100 mm. And when crossing is the same, 100 mm. So if you have 13.8 kV, a parallel distance must be 200 mm and 100 mm for crossover. 33 kV, 500 mm, and 100 mm with reinforcement in the ducts when crossing. Okay, so 69 kV, parallel distance is 1000 mm, and structure for 500 mm beyond power cable for crossover. So a written agreement on reduced clearances shall be obtained from the relevant STC manager or inspector and the relevant service owner if applicable. Furthermore, for a safer working environment, the minimum required separation clearances from other utilities must be maintained. Okay, so when crossing and adjacent to an existing utilities, standard separation should be observed as a minimum requirement. Contractors should also meet the requirement of utility owners if it is specified differently in the permit. So in case of difficulty to maintain the standard separation, site instructions shall be issued for waiving the standard conditions on site. So let's move on to surface breaking. Surface breaking. It is very important that during surveys, a surveyor must fill up the survey form prescribed by STC to identify the type of pavement in the field. This will give at least an accurate BOQ to the project later on by the designer. As a general rule, the contractor must maintain rules and regulation of STC during implementation. Depending on the type of pavement, the contractor must make sure to use the suitable equipment to do the work. Like if you use a trenching machine, then there is no need to use an asphalt cutting machine, of course. However, if you have a standard trench like 400 mm width and more, an asphalt cutting machine is required. Avoid wide trench and surface breaking as much as possible because it will cost you a lot to restore this pavement if it is beyond STC specification. And of course, those extra material used cannot be charged to STC. It is more likely that when breaking customer tiles, there's a big chances that customer might ask you to reinstate the whole area, like the driveway, for example. So it is very important to take photos or pictures of that area that you have break, okay, to justify your work. All debris shall be removed within 24 hours maximum. Next is trenching and excavation. Okay, so trenching and excavation. First, let us differentiate soil test and test pits. When do you guys need these soil test and test pits? Okay, so first of all, a soil test is used to confirm the changes in the soil type that could impact the civil works, most especially when you are installing a manhole. Okay, so while test pit, on the other hand, is used to determine the actual or existing utilities underground, or it could be also used if you have doubt about the actual, actual existing utilities underground. So this is very important that so that implementation team will not be surprised during execution. Okay, so when do you guys need this soil test? Okay, soil test can be used at the maximum of 1,000 meter if no manhole or handhole. It could be also used if there's an apparent change in soil type or if there is a reasonable doubt, as we said a while ago. Trenches for long distance at 500-meter intervals, okay, at the major crossings, and when setting a manholes. Okay, so test pit, on the other hand, test pit can be done at every manhole and handhole locations. Okay, test pit shall be used as a test for the soil and utilities identification. When GPR report is unclear and there is no reasonable doubt in the location of the existing utilities, okay, if the maximum distance between two manhole handhole exceeds 1,000 meter, test pit must be done at the middle of the span. When there is an apparent underground structure that risks to impact the build, test pit is also applicable. Okay, excavation. As a definition, excavation is performed by a mechanized machine having different sizes of buckets. During excavation, contractors must observe the following STC rules. Okay, so a trench must be straight as much as possible. This will prevent cable of getting longer during installation. Always avoid breaking the pavement beyond STC requirement. Okay, you guys also need to remove debris from excavation immediately where there is frequent traffic in the area. Where there is existing utilities, trench must be 50 mm away from these utilities. Inform immediately the owner of damaged existing outside plant utilities if this happens. Okay, so always secure if there are exposed existing plants in the field. Clean all entrances going to the building at all times to avoid complaints from the owner. Okay, bottom of the trench must be smooth always to avoid damage to duct later on. Okay, where the bottom is rocky, a 10 cm layer of compactable bedding material is always recommended. Lastly, always maintain safety precaution on site from time to time. Okay, trenching. This implementation technique is the most preferred method for the deployment of telecom infrastructure, as it offers faster performance compared to other deployment trenching methods. As we said earlier, before starting any civil works like trenching, you guys need to have a look around the route to make sure that you can deliver the work and to make sure that everything is all right, like free from any obstruction that may hamper your implementation later on. Then do some ground scanning as well to prevent from any damage to existing utilities underground. So in the screen, you can see a table which explains you the criteria of trenching in highways and main roads. Like for example, if you have a road width of 8 to 10 meters, okay, the trench the trench distance from the pedestrian footpath must be 1 meter away. Okay, while if you have a road width of 10 to 15 meters, the distance from pedestrian footpath trench must be 1.8. And if you have 15 to 20 meters road width, your trench from the footpath must be 1.8 meter as well. While 20 to 23 meters width road, 2.5 meters trench must be observed from the footpath. Okay, so you have 23 to 26, which is 3.2 meters away from the footpath. You have 26 to 30 meters, 3.2 as well. 30 to 40, 3.2 as well. So 40 to 50 meters width of road, 3.75 meters away from the footpath. Okay, so 50 to 60 meters road. Okay, so 3.75 away from the footpath as well. So if you have 60 to 100 meters width of road, so the trench must be 4 meters away from the pedestrian footpath. Okay, so let's discuss about the standard trenching for a long distance network. In this slide, you will see the different types of trench and duct configuration. Depending on the type of pavement that has to be trenched, applicable trenching method must be observed always. As a standard, depth of a trench in a long distance network must be 1.2 meter from the top of the duct with respect to the ground level. When you have a trench outside the city, ensure that you are using the right machinery for the type of pavement. Like if you have a sandy or soft soil, as a priority, a mole plowing machine must be used always. However, where the pavement is hard or rocky, an excavator with the use of a jackhammer must be also used. So when you are outside the city, okay, a single 110 mm PEC duct with the pre-installed 5 by 32 mm subducts must be used, buried by plowing machine into a depth of 1.2 meter or installed in a standard trench of 400 mm width by 1.2 meter depth from the top of the duct. For mole plowing method, detectable warning tape must be installed 800 mm from the top of the duct and 400 mm backfilling of fine materials for the remaining trench with respect to the ground. While for normal trench of 400 mm by 1.2 meter depth, the first layer of backfilling will be 150 mm of fine ginseng, including the 100 mm sand bedding. Then you have 800 mm detectable warning tape located from the top of the duct and 400 mm backfilling materials of not more than 2.5 cm diameter of backfilling materials. When passing through cities, priority should be always by the use of existing civil infrastructures. However, in case that it is a greenfield area, the use of either a 1 by 2 or a 2 by 1 110 mm PEC with the 5 by 32 mm subducts is also permitted. Okay, so this corrugated 110 mm duct could be installed either in a standard trench of 400 mm width by 1.2 meter depth or in a special trench of 200 mm by 1 meter depth of trench. But guys, please take note that the 1 meter depth is up to the bed of the trench and not to the top of the duct. Okay, so on the right side of the slide, you can see the layering of backfilling materials. Okay, so you have a normal trench of 400 mm width and a normal trench of 200 mm width. In a 400 mm width by 1.2 meter depth, the first layer of backfilling material is a fine-tuned sand. Okay, then we have a concrete mix of 300 mm. Okay, that is for the 400 mm normal trench. And for the special trench 200 mm, the first layer is a fine ginseng, okay, which is 240 or 250 mm of backfilling material fine ginseng. Then we have a backfilling material of another 150 mm, okay, fine backfilling materials, and a concrete mix of 300 mm. Then another one, you have also asphalt of 100 mm. Okay, small trenching. As you all know, guys, small trenching is used primarily in the feeder and distribution network. Our trench profile in this network is 200 mm wide and 500 mm deep if it is unpaved area, and 600 mm if it is asphalt area. The trench can support up to 20 way of 32 mm main ducts and another 24 way of 20 mm drop ducts. For the layers of backfilling materials, first layer with respect to the trench bed is a fine-tuned sand of 300 mm with a detectable warning tape on it. Another 250 mm of concrete layer and 50 mm hot mix asphalt layer, as shown on the picture to your upper right. Okay. So standard drops in small trenching. What are the important considerations? Trenching for drop cables shall be 200 mm wide and 400 mm deep if it is unpaved area, and 400 mm if it is asphalted. Ducts from the fat to the customer shall be 24 ducts by 24 by 20 way by 20 mm in diameter maximum. Okay. So each location, whether it is ODB, OSB, or FTB, gets two drops as shown in figure 12 to the right. Okay. The duct location shall be in the nearest boundary line outside the customer's building. Ducts are placed in the trench such that they do not overlap. Two ducts are placed in each location. For the backfilling materials layering on the trench, first backfilling is a 150 mm fine sand with a detectable warning tape on it. Okay, so another 250 mm of concrete mix and 50 mm of hot mix asphalt layer. Okay, I just want to show you some of the pictures that were taken during the implementation phase. In the first picture on the upper left, trench is not aligned to the manhole. Okay, it only means that the contractor did not follow the correct process prior to implementation. If you notice the picture on the upper left, there is an existing cable beside the trench, preventing the two cover handhole to be installed along the trench. This resulted to a disaster just because the team didn't perform ground scanning, test pit before executing the trench. So the two pictures below is just to give you information about improper surface trenching and restoration and also wrong trench profile. Okay. Okay. So microducts in long distance network. Like the standard trench in implementation for the long distance network, the trench profile for microducts are just similar. It's just that we change the material. So again, trench profile will be from 1 meter to 1.2 meter depending on the soil condition. Also, priority is always given to mole plowing method. Okay, so when passing outside cities and when crossing towns, a one or two bundle of four-way of 25 20 mm microducts has to be used. For backfilling materials and layers, microducts installed in long-distance network compared to standard ducts are just the same. For direct buried microduct, a detectable warning tape must be installed 800 mm from top of the duct. Then another 400 mm of backfilling material up to the ground level. All right. So for excavated trench, 1.0 meter cover also needs to be observed from the trench bed. Okay. So 150 mm of fine ginseng is required for the first backfilling. Then another 800 mm with warning tape. And finally, 400 mm again of backfilling materials up to the ground level. If you are using a trencher for 200 mm width by 1 meter depth, first layer would be 200 mm of fine ginseng, then another 400 mm of backfilling materials with warning tape on it, then 300 mm concrete mix, and finally 100 mm of asphalt, okay, for the final layering. Okay, so microducts in the feeder routes. In all feeder routes for fiber optic cable, use manholes or a two-cover handhole in all civil works and trenching. Okay, so the span distance between manholes in the primary or feeder routes shall not exceed 2,000 meters due to the limitation on the cable installation technique. So in this slide, first picture is used from exchange to FDT or MSAN. Okay, so ducts in the primary or feeder routes shall have three bundles of seven ways of 25 20 mm main ducts and a 12 bundles of four ways of 12/8 if it is shared, or 12 bundles of two ways by 12/8 if no sharing for the drops. While the pictures on the right side, this is used between exchanges to FDT or MSAN. Okay, so for a mixed trans profile containing three ways of 768 mm of PEC or HDPE ducts for copper network and a three bundles of seven ways of 25/20 for fiber network. Then the recommended reaching depth is 600 mm and the width is up to 200 mm. Microducts in the distribution network. In this slide, you will see two pictures which is used basically between FDT and FAT. Okay, so on the left side, this duct configuration is used if there is sharing in the drop and main ducts, while on the right side, if there's no sharing on the drop ducts. Trans profile for the distribution network will be 130 mm wide and 550 mm deep if it is unpaved, and 600 mm deep if it is asphalted. Inside the trench, a 3 by 7 way of 25/20 mm main ducts and a 12 bundles of 4-way of 12/8 drop ducts has to be used if it is shared, and a 12 bundle of two-way of 12.8 mm drop ducts if there is no sharing. Okay, so remember that if you have a 12 bundle of two-way of 12.8 mm drop ducts, the height of this bundle will be 48 mm. Okay, so if you have a 12 bundle of four-way of 12.8 mm drop ducts, the height will be 96 mm, while three bundles of seven-way 20 main ducts, a height will be 205 mm. Okay, and for the backfilling materials in this trench, okay, so first backfilling will be 400 of backfilling materials, then 250 of concrete mix, and finally 50 of hot mix asphalt. All right. All right. Mini trenching in the draft network. There are six pictures in this slide, as you can see. Okay. So first picture on the left is for the duct with sharing, which contains a 12 bundle of four-way by 12.8 mm drop ducts if there is sharing, in a 12 bundle of two-way of 12.8 mm drop ducts if there's no sharing. Okay, the pictures below is just an illustration of the drop ducts to the customer side with either shared or no sharing. On the right side is the microducts for mixed trench profile. All right, so where there are copper network along with the microducts in the drop network, a 12-way of 50-45 mm HDPE drop ducts must be installed, together with 12 bundle of four-way of 12.8 mm drop ducts for fiber network if there is sharing, or a 12 bundle of two-way of 12.8 mm drop ducts if there is no sharing. All right. Okay, guys, so these are just some of the pictures taken during inspection on the field. Okay, the first picture on your upper left side, as you can see, there is poor trench causing damage to the pavement. Sometimes you cannot avoid this kind of trench. Sometimes it may erode because maybe the pavement is not properly restored during that time. Okay, so another picture on your right side, trench were not aligned to the handhole knockout windows, causing a large opening to the handhole wall. So if you have these very big opening, this will cost you a lot of money to restore this pavement, because you will place a lot of concrete mix, backfilling, okay, extra time to reinstate this big opening, which at the end will cost you a lot of money to restore this you know wide trench. Okay, so another picture on your right side, as you can see, there's no proper sun bedding, no plates between ducts and spacers not properly installed. There is also a very shallow trench. It's around 20 mm from the top of the duct with respect to the ground level. No proper signs and barricades. So what will happen if you have these issues on site? You will face a lot of penalties. Okay, so you have also U-guards here were not properly installed on your low left side of the slide. So operation accepts only, actually in the beginning it's 300 mm, but nowadays they are now accepting 100 mm. Okay, so another picture on your right side below, top of 7-way by 25-20 mm main duct is only 20 centi below the ground, excluding the microducts. Ground to the duct clearance must observe at least 30 centi depth. All right. So last picture on your right side below, okay, there is a diagonal trench done by the contractor because what happened to this trench is that they follow what the designer did or show in the design. And as you know, guys, doing a diagonal trench on the street is not permitted. Okay? In some regions, like Hail in the north, the entire trench is backfilled with full concrete mix without milling and paving. To be able for the contractor to claim for that material and services, they must have to use the PU of breaking and reinstatement instead of milling and paving. So in this case, you make sure that you are using an M25 concrete mix to cover the trench. All right? So let's move on to the standard DAC configuration between handhole 00 and FDT. Okay? So a 4x4 configuration of 16-way of 32 mm must be installed between handhole to the base pad. Always take note that all O-rings and O-rings with the stripe pipes must be installed on the left side of the base pad, as shown on the picture on your upper right side. Then the remaining pipes, which are the black pipes, must be installed on the right side of the base pad. Okay. So, however, if you are using a microducts in the FDT, that configuration would be first, okay, the green bundle of 7-way of 25 mm main ducts should go first to the right side of the base pad. Okay. Then blue and yellow bundles must go to the left side of the FDT, shown on the pictures on your right side of the slide. Okay. Trenchless methods. By the way, what are the trenchless methods that we have now in STC? So we have HDD and truss boring method, right? Okay, but what are their differences? Let's differentiate these methods then, by the way. Okay, a truss boring is typically performed by placing an auger equipped with a cutting head inside a 220 mm to 1500 mm diameter steel pipe. In STC case, we have only 110 mm to 600 mm of HDPE or steel pipe. For thrust boring, the direction of the bore is unidirectional, whereas an HDD has a pilot bore with the similar function of the thrust boring, but it's just that the direction of the boring is multi-directional in this case, meaning that you can drive the pilot bore in any direction for the HDD. Trenchless method should be only considered in situations where trenching is not allowed without interfering the traffic and where there is expensive repair works and reinstatement. So in the table, you can see the different bore sizes, okay, used in HDD and truss boring for both in the long distance and feeder network. So we have 110, we have 300, and we have 600 mm bore sizes as well. Okay, so for 110 mm bore size, for example, in a long distance network, we can install one bundle of 4 ways of 2520 microducts. Whereas in the feeder network, you can install, okay, you can install a 4 by 32 mm standard ducts or one bundle of 7-way 2520 mm microducts. For 300 mm, which is, the very common bore sizes that we are using in the field, okay, So for a long distance, you can install a four-way 110 corrugated PEC pipe, okay? And in the feeder network, we can install also a four-way 110 mm standard ducts with a 4 by 32 mm subducts on it, okay? Or three bundles of 7 ways. And for the 600 mm bore size, in this table, there is no actually information because we are not using this from time to time. But anyway, you can install a 110 mm, okay, pipe and another or a 2520 mm microducts, okay. So horizontal directional drilling. What we haven't mentioned here is, you know, to be able to prevent the ground from swelling, okay, a 1.5 minimum meter depth shall be observed always. Okay, the most suitable boring technique for a particular site will be dependent on the following considerations. We have the number and size of ducts or cables to be installed and their length are required. Okay, type of soil and condition is suitable for directional drilling. Straight or curved profile route is required, and there should be no restraints on size of equipment used. Directional boring requirements. So below are just some of the points that you guys need to follow during implementation. So when required, install a mold tape and seal the duct ends always. Multiple ducts can be passed through a single bore. It is required that there is a minimum spacing of 10 times the diameter between single bores where there are multiple bores, okay, where D is the diameter of the largest duct. To be able that the ground will not swell, you make sure that the minimum depth of the bore must be 1.5 meter with regards or with respect to the ground. The final depth is to be determined in conjunction with the boring contractor, with the minimum depth to be achieved wherever possible. Okay, so when installing duct banks of ducts in a bore, install a duct in a such way when practicable that the duct profile is the same as the entry and exit, right? So we also need a bore log of the final depth, okay, and the location to be included on the as-built drawing as a permanent record for the installation. Okay, so you can see figure 17 below. This is horizontal directional drilling on a highways when crossing highways. Okay, so when crossing highways using a directional boring machine, okay, you make sure that you must have at least 15 to 20 meters space in one side so that you can, place your equipment and to be able to do your job in appropriate way. Okay, so on the right side, this is just details about the process of the installation of a trenchless method. Okay, so I put two links below. Okay, you can open those links so that you can view a video with regards to how this HDD and truss boring method are to be done. Okay, so watch them and you will have more information how ACD and truss boring are performed on site. Okay, next is deck handling and installation. Deck handling and installation. In this slide, you may see the proper and improper way of handling the ducts. When withdrawing any materials, either it is a duct, a manhole, a handhole, a cable, or cabinets from STC or vendors, contractors shall make sure that all materials must be all in good condition. You should not receive any material which has defect or not usable because once these defective materials are installed on site, the inspector or STC has the right to reject your job and charge the contractor for that particular defect, or in a worst case scenario, you will bear all the cost of replacement, including services. All materials should be handled with care during transport, and ducts shall not be stored in a direct sunlight for more than 5 days. Always use a decoiler to facilitate the duct placement. Okay? All ducts shall be capped and covered during storage, transport, and installation. Below are just some of the pictures which will guide you about the proper and improper way of storing the duct reels. Okay, first on the left, when storing duct reel, you guys shall make sure that reels will have a separator in order that reel will not be, will not bump each other, causing them to be broken and later cause deformation to the ducts. Also, ducts shall not be stuck on top of each other where edges of the reel is touching the ducts. Correct way to stack them together is using the sides of the reel on top of each other as shown on the third picture on top. Okay? When using a wedge to prevent the reel from rolling, wedge should be longer than the width of the reel so as not to touch the duct and will get deformed later. Also, when using a forklift to transport the duct reel should be positioned vertically and not horizontally as shown on the upper right pictures. Okay, so below pictures are just some of the example of how are you going to handle the drums. Okay, you can either use a forklift, you can use a belt with wide opening, or even you can use a rope. These are just some of the pictures taken during inspection in Azizia. So as you notice, these ducts were not stored in a proper place where direct sunlight is visible. I'm just surprised that this is the reality during implementation. And as I said, guys, contractor must have proper storage on site to prevent pilferage and damage to materials. So better watch out because once the inspector caught you, okay, the inspector will give you many deviations of doing these bad practices. Duct installation. Before duct installation, contractors shall make sure that the bed of the trench is free from any sharp objects and it should be flat as much as possible. Trench must be poured with 10 to 30 mm thick layer of well-graded sand, substantially free from lumps and particles more than 6 mm in diameter. Maintain maximum bending radius of duct to 20 times the diameter to prevent duct from kinking. Okay, so always put a nylon rope and end cap to standard ducts and end cap only for micro duct. As much as possible, maintain a 200 to 250-meter pulling distance. Okay, so as not to put stress and tension to the cable. So below pictures on the left, okay, so ground surface must be always flat, as we said, and there should be no twist on the duct bundle. Okay, so on your right side, these are the proper equipment when installing a duct. So duct should be always put in a horizontal decoiler or vertical decoiler or even put on a trailer. Okay, so there is also chamfering tool. All right. Okay, so this is just a continuation of the previous slide. The most common duct installation practice is by using a static vertical decoiler, as you can see in figure 26. because this will accelerate setup time and installation time as well. So another installation practice is by using a jack stand. Okay, as you can see in figure 27, it is very critical that the duct be decoiling through the bottom of the drum as opposed to the top. Okay, so ducts shall be properly arranged on top of each other by suitable spacers. Remember that there is a spacer intended only for standard and micro ducts. Okay, so you guys always install first the main ducts at the bottom of the trench, followed by the drop ducts. Special attention must be given to the installation of the micro ducts and their spacers. The contractor is required to install the spacers prior to the placement of the ducts. Due to the reduced size of the trench, the contractor will not be able to place spacers after the ducts are laid in the trench. So therefore, the spacers are installed first to build the duct formation outside the trench. Then all the ducts are laid inside the trench. Once all ducts are installed, the contractor must close the spacer tightly. Okay, so ducts are installed in trenches with a minimum separation from other utilities, okay, or any applicable local utility requirements. The ducts are to be laid in bends not less than 6 meters in diameter. Okay, so when multiple ducts are installed, passing through manhole, ensure that the lower bundle of the ducts are reserved for STC. Okay, so on the right side, these pictures of figure 28 is just to show the non-approved method and the approved method of duct installation. All right, so let's continue, guys.